This is a special video that we really have need for. It's on setting up the flywheel for the flame engine. This is the part that we will eventually make. Up until this point, we've been doing everything setting tool offsets and setting work offsets using what I call the manual method, where we trap paper and so forth. This machine came equipped with a couple of different probing systems on there. And so we're going to be using the probes for this, and because of the difference in this, I want to make the video so you'll have this. There are actually two different probing systems on here. One of them is used to calculate the length of the tools. The other one is used to set your origin. Now, I'm going to go back and relate to what we've done. On the manual mill, a manual setting, we use the work offset, generally G54, to set the X value and the Y value origin. We did not set a Z. In fact, Z had remained 0. So what I saw when I looked at work offsets was a large X negative number and a large Y negative number, and a 0 in the Z column. On the tool length offsets, I saw a large number of negative Z values depending on the length of the tool. So that's how we took care of X, Y, and we used tool length offsets to handle the Z on the manual machines. Many companies, they do not spend the money for these probes. It's about $6,000 for the probing system. It's a lot of money. I don't know how we managed to get one, but I'm glad we did, so you can at least see this. When we're probing using the probe system, things are done a little bit more differently. What we do is we use our work offsets. We set X and Y and Z. Once we've completed this process, we'll see large negative numbers for X, Y, and Z. Now, all of these come from machine home. So not only will we be locating X and Y origin, but we're going to come down and probe the top of the part and establish Z0 from the top of the part. Now, how do we handle the tools? We know the tools are all different lengths. When we use a probing system, the tool lengths are registered as positive numbers. So instead of looking at our tool length offset page and seeing a large group of negative numbers, we're going to look in and see some shorter positive numbers. Those numbers are actually the measured length of the tool. Now, the way the system works, when you address G54, not only does it go find the X and Y, but it finds Z0. It subtracts off, which is a positive Z number, the length of the tool, and lo and behold, it knows how far to go down and get to the top of the part with that particular tool. So it's a little bit different system. It's a great system, and you'll see why as we go into this. But once I have the length of those tools calculated, if I don't take them out, if I don't change them, or if I don't break them, I can use those tools on a flat part just by having a large Z value down to this, and then I can take another part and stand it up, reestablish Z here, and that same group of tools will work over here. So if I've got to work on several sides of a part, by having the tools with positive Z values in there, the actual lengths measured, I can assign one work offset for this face, another work offset for this face, and the same group of tools will work for all faces. So it really makes setting up faster. It's unfortunate that it costs so much because a lot of companies don't spend the money. Okay, to get to the probing cycles, the first thing I want to do is set the tool lengths themselves. Now, this part, we called up this the other day and loaded all the tools in here. There are, it says 8 tools that are in here to be set. One of them is a shell mill, the very first one I've got loaded in here. All of the others are smaller tools that, you know, basically have a point on them or something that I can measure easily. Back in the back corner is a tool setting probe back here. And so what I want to do is get all of these tools over there and measure off of that tool setting probe. And you'll see how quick this is. To do the shell mill, I have to actually position the tool over that probe, because if I were to just simply say go over and measure that tool, the probe would try to hit in the center of this and it would not be accurate. So I have to position one of the cutting teeth over the probe itself, and then I'll call it the cycle and you'll see how this works. So I'm in the jog mode, and shell mill over. I'm going to bring it down and just position it over one of the teeth. Again, I'm going to be about 1/4 of an inch over one of the teeth. So I'm about 1/4 of an inch up. Now you have a range up to 400 thousandths. If you position over 400 thousandths, the probing cycle is set up to go looking for something to touch. If it's more than 400,000, you get a alarm message that says probe failure. It did not find what it was looking for. So normally I get about 1/4 of an inch up, and I've just positioned the tip of the insert right over the probe. Now to get to the probing cycles, this is real simple, and you'll do this a lot. It's in the edit mode. Over on this side, right here in the center, it says program conversion. I'll hit this 3 times. Brings up a different screen. On the right is a group of pre-programmed things that we're able to do. I can come down. You've got 3 areas where we can probe. One is a spindle probe, which has to do with probing your origin, 1 through 9. There are 9 pre-programmed cycles there. Fill in the blank. Spindle probe 10 through 18. There's some other options down there. And then tool setting. It's the tool setting cycle we're going to do. Anytime we're measuring tools and using the probe back here, we'll go to tool setting. I'll just press enter. And these are the options that I have. And there's several here. Number 1, and by the way, they're listed over here. If I use this one, it'll do the length of a single tool. This is great if I break a tool or I need to replace one. I can just use that and touch off again. I've got a new length set for that. This one is going to ask me what is the tool number for the one I'm doing. The second one here, probably can see, there's a shell mill with the tool insert positioned over the little probe right here. This is the one we'll use right now. Again, this needs to be positioned over that button before using it. And there are others down here. The ones we'll be talking about, we have the ability to do a group of sequential tools, 2 through 6 or 2 through 8. We have the ability to do random tools such as 2, 5, 12, 17, and so forth. I'm going to use the shell mill. I'll just press enter. It says up here, what is the tool number? There's no need to put a T here. It's asking for tool number. I'll just put a 1 and press enter, and that information is filled in up there. I'll always get a little box right here. Select create a program. This is a one-time deal. I'm not interested. Add to the current program. Again, I'm not interested. Number 3, run it through MDI. I'll always use option number 3. So I'm just going to press 3. And this is the little macro or sub-program that's going to do this. So I'll press enter, and you can watch what happens on the tool probe as I do that.
Don't press start. Hit push program cycle start.
Okay. And the machine is cold, so warm it up a little. It actually goes down and makes 3 hits. It makes a fairly heavy hit, it backs up, and then it eases down 2 more times to confirm that. Now, if I check the tool length offset page here, the number is now positive 4.4737. I know before it was a negative number because I just run a part for another class. So it's a positive number here. So that will take care of setting the tool offset, that particular tool, from its gauge line, which the gauge line is really the back of this where it sets into the tool. The length of that tool is approximately 4.5 inches roughly. Now, the other tools that I'm going to do are listed here, tools 2 through 8. So I can use the probing cycles to get all of these at one time. And this is what will happen. To get to the probing, it's edit, program conversion 3 times, 1, 2, 3. I'm going to go down to the tool setting cycle again. Press enter. Now the option that I have here, down here in the middle, measure the length, auto length for sequential tools. These are tools that are in order. This is the one that I'm going to use. I'll press enter. It says, what is the first tool that you want to set? Well, I've already set tool number 1, so I'm going to do tool number 2. Press enter. What is the last tool that you want to set? Number 8. Somewhere here. Press enter. There's the little box. Again, I'll use number 3 to run out of MDI. And I'll press cycle start. So the machine knows where that button is. Again, it'll make each tool hit 3 times. Or 2 times. There. So if we're going to do a shell mill, we have to pre-position, then use the cycle. If I need to do a single tool, I don't have to pre-position because the machine knows where that button is. I can do sequential tools or I can do random tools. So you see, if you've got a program with 30 tools, this is the way to go. And again, the nice part about it is that you have a group of actual tool links that will work with any height part out there. We just have to set 0 on our work offsets. The tool length offsets are not necessarily tied to a work offset. They're just a little bit. You kind of hate to go back to trapping paper, don't you?
Much more accurate.
Nobody wants to run the other machines after this. You have to know both methods. The hardest part was finding the tools. Now, when I go into the offset page, tool offsets, all the tools now have these positive numbers in here. Tool 8 has got the shortest number, 3.556, so forth. Well, that was just a little short tool right there. So you can kind of see how this works. We've got positive values on our tool links. Now to set the origin, I need to call up the probe for setting the origin. That, on this machine, that's tool number 24. So I'll go into MDI, P24, automatic tool range. Here's the probe for setting the origin. The little ceramic stylus in there is $100. So if you break it, bring $100 to pay me. Always, always, always think about what direction you want to take that thing when you get through using it. Don't go down if you need to go up. You think about what you want to do first and then turn your dial. I'm going to reposition. I'll go into jog. I'll go to X mode, come over a little bit. Probably a while, come back this way a little bit. Bring the Z down. You need to get the little red ball down below the surface of the part. Again, I'm about 1/4 of an inch away. Now, one thing I need to check here, and I'm going to go into edit to do that. This program uses G54. That's one of the things that I'm going to be asked is what. Now, we're going to set up the other one in just a minute. But you need to know what work offset to put all of these numbers in. So it's G54. I'll go back now that I've got it in position. I'll go to the probing cycles. And I'll come down to spindle probe 1 through 9. Hit enter. Again, we have several options. Number one, the first one is to probe a bore. So I can put this in the approximate center of the bore, and it will go find the 4 sides and find the center of that. The question is that you see the little mark here with the number missing. It's going to ask what is the diameter of the bore. The next one says probe the X plus surface. Basically, the probe is to the left. It's going to be probing to the X plus direction. The next one naturally is going to be carrying your probe back the other direction. So, and down here you have an option to probe the front of the part. Here we probe the back of the part. So it's this one right here that I want to use probing in the X plus direction. Press enter. It says what is the work offset? I'll put in the 54 and press enter. I get the same box. Now you can come down to 3 like that, or you can just hit 3. And when I do this, we'll see it go over and probe the side of the part. Now the location of that has been set to X0. It's compensated for the diameter of the ball. Everything's done. I'll reposition to the front of the part and jog wide. Again, I'm about 1/4 of an inch away. I'll hit edit, program conversion 3 times. Come down to spindle probe 1 through 9 again. And this time, I believe it's here. I want to probe in the Y plus direction. You can see the little dots there to tell you what to do. Press enter. It says what work offset do I want? It's 54. Press enter, 3, and cycle start. So we've just located the corner of the part. Now the last thing that we need to do on this one, I'll go to the offset screen and hit it again. For G54, I've got a negative 16 inches plus in X. I've got a negative 12/8 in Y, and I've got a 0 on the Z. This is a holdover from when I came in to set something manually. I'm going to go now and probe. I need to reposition my probe. Z up. Positive. I'm going to move into the part. Again, I'm about 1/4 of an inch in, 1/4 of an inch up. I'm going to go edit, program conversion 3 times. Spindle probe 1 through 9, enter. Now, by looking at the pictures, I would hope to be able to find which one would probe the top of the part. You begin to see it's not that complicated. Right there, that would probe the Z surface. So I'm basically going to set Z0 right now from machine home. So I'll press this. What offset do you want to put this under? 54. Enter. 3 to run it. And I'm going the first thing to pick this up. Z HAAS. Now when I come look at my offsets now, notice X, Y, and Z all have negative numbers. Those are numbers as registered for machine home. If I look at the tool offsets here, all of the tool offsets are positive values. So using the probing system, that's what you're going to get, a negative X, Y, and Z in your work offset, and you're going to get positive numbers here. Now I can put in a part that's a lower part now, and I can reset my origin, and the same group of tools are going to work better. One other thing to show you how there's really a lot of cycles in here to experiment with, and if you were a mind to, you could do this. Let me go to X, pull over, bring the Z down a little bit. Bring the Y down, X over. And what I've done is I've actually taken the part and I positioned it out at the corner so the tool can go to the end. There's a 1/4 inch clearance and there's a 1/4 inch clearance underneath it. Basically the tool can go either way. I've got it down in position. I'm going to go edit, program conversion 3 times. Come down to my spindle probe 139. There's a couple of options down here. Right here, I can probe the corner of the vise. Probe the center of the block, starting from the center. I may have gone to the wrong cycle. I apologize. Let's do this. I'm going to go down to the very next one. 10 through 18. This is the second set of probing cycles, 10 through 18. Right here, it allows me to program an external corner, do both X and Y at the same time. Notice I've got a little thing here. It's going to ask me how far can you move in each of those as you do it. So I'll press enter. The work offset up here is going to be 54. Now the X width is how far should I step over in between hits. It's going to make 2 hits for each side. I'm going to put on the X value, I'm going to put 2 inches. For the Y, I'm going to put 1 inch. And the next question says, what corner do you want to probe? It makes a difference where I position it. I can go corner 1, 2, 3, or 4. Of course, you have to pre-position. I'm going to do program corner number 1, enter, number 3, and let's watch you do all of it at the same time. First hit, move over an inch. Second hit. First hit, move over 2 inches. We just set X and Y at the same time. Everybody see how that works?
So you don't have to do them.
You can do them separately. Just be sure when you position that you check and be sure that it will go both directions at the same time. When you all start doing this, I'd suggest just do them one at a time right now. I'm an expert. I can get by with this. Okay, what I want to do is I'm going to get this up. That one. Now we're going to put in the flywheel. Now, what is the diameter of this thing? Do you remember? What? Will somebody please check? Well, I guess I can check. I've got a tool here, handy dandy. It's 3 1/4. Okay. It's also been rough machined so that it's 50 thousandths above the finished thickness. The shell mill is going to come down and cut off 50 thousandths in sizing. So when I come down and touch off my Z, in order to find Z0, I'm going to have to move down 50 thousandths. And we'll do that electronically like we've been doing. Now the tools are already set. All I need to do is probe my Z, and then I need to establish the XY origin, which is going to be in the center. To do that, I'm going to bring my probe over and get in the middle of this and touch off and get my Z first. Okay, I'm about 1/4 of an inch away. Edit, program conversion 3 times. Well,
It did edit, but it kicked back out or something.
edit.
Oh, stop.
I found on these machines, if you push a button and don't do it, go to memory or back to edit or something. It's kind of like jar clues. And then, by the way, on this thing here, if you get tired of all of those clicks coming down, you can go up. You can get the same place by going up. I'm going to go to spindle probe 1 through 9. I know that's where my probing Z is. I am going to select that. Press enter. It asks what work offset. 54. Enter. Number 3. And we'll probe the top of that part. Now, since the part is 50 thousandths too thick, I'll immediately, before I move on, I'm going to go to offsets. I'll be sure I'm in the tool offsets. Oh, it's wrong place. I don't want to be there. I want to be in the, don't change the length of the tools. Go to your work offsets here. Come over to the Z. I want to bring this down 50 thousandths. This number is going to actually grow. It's going to be a longer distance down to Z0. So I need to do it. In order to make that number grow, I've got to put a negative number in. So I'll go negative 50 thousandths. Please do not put negative 0.5. I'm looking at something here. Please don't do it. It's 50 thousandths too thick. Now, if your part is 45 thousandths thicker than 1 inch, you would move it down 45 thousandths. If yours is a little more, bring it down accordingly, okay? I've got 50 thousandths there. I'm going to press this. This number should grow. It's 18,380. It's 431. So we took care of the Z value, okay. Next thing I want to do is I want to get fairly close to the center. You don't have to be exactly the center, but just somewhere close. Now, there's several things I want to show you right here. This probing cycle, when I enter that, it's going to move over, it's going to drop down, it's going to probe the front, the back, and the 2 sides. Now, looking at that part, there's not a lot of material sticking up above the vise. So before I do all of this, I want to see, one of the questions it's going to ask me is how far can I go down before I hit anything? And I need to give it a number, negative ½ inch or negative whatever it can be. I don't know what that number is. I just know that I don't want to hit that vise and break that probe because I don't have $100 not this late in the month. So here's a really nice technique. I'm in the jog mode. I'm in the Z here. I am going to go to position. Now, I have several options for hit position again. Let's see, on this control page down. I'm in the operator jog position. Notice I have the Z axis hit here, so the Z is flashing. So I'm in the operator, I hit position until I got to where it said position operator. The Z is flashing. I'm going to reach over here on the side where it says 0 return. I'm going to press origin button right here. I expect the Z to change to 0. This has nothing to do with G54, has nothing to do with machine home. This is like setting your digital readout on the lathe to 0. I'm going to press origin, 0, Z is now zeroed out. So what I'm going to do with that, by the way, while I'm at this, I'll just do 0 them all out. I've got the X flashing. I hit origin again. I've got the, I'm just touching the button. I've got the Y flashing. So that's where the tool is setting right now. Now that is nothing but just for my own benefit. What I'm going to do is go in the Y axis. I'm going to count negative. See, I'm really careful around this probe. I've got off the part. Now I'm going to go into Z. And I'm going to bring the probe down I stopped about a 1/16 above the vise. Now from where I was setting, I went down about 460 thousandths. So let's just say 450 is a safe number. So when it asks me how far down can I go, I want to go down 450. Now the reason I set these, I'm going to go back up to 0 here. And I'm going to go back to the center with my Y. Now, I can go down 450 and not hit anything. That's my plan. Now I'm ready to go into my probing cycles, edit, program conversion 3 times. And I know these are in the second probing cycles. I'm going to go up to get down. Spindle probe. When it says spindle probe, it's probing the origin. I'll press this. And you can probably tell right here, this is to probe a boss. We have a raised area. It's called a boss. It's going to ask me several things. It's going to ask me the diameter of the piece of material, which is 3 1/4. It's going to ask me how far to come down for the hits, and it'll ask me what work offset do I want to use. So those 3 pieces of information I expect to get. Enter. First thing it says, what is the work offset? It's 54. Enter. The diameter of the material is 3.25. And the depth that I can go. Now I believe I have to put a negative right here. It's not like in a spree where depth means negative. So I'm going to go negative 0.45. That's the safe distance that we felt like we could go down. Right here. I'll hit number 3. And see how you really want to check and see how far you actually can go down. So we've just found the center of that part. Now that's compared to the old coaxial indicator that you had to turn around and all of that. Really a cool tool. I like that. Cool tool. I'm going to go into jog. First thing I want to do is pick that tool up. Now the tools were already set. I just set Z and moved it down 50 thousandths. And I probed the boss and I've established my XY origin. So I'm going to go to the offset page. I've got locations on G54 for all of that stuff right there. There's one more thing I want to do to set this up. And that's the HAAS machines and other machines have got programmable cooling. This is because this part is steel. If we neglect to get the coolant on the part, if you turn around and you're doing something and it tries to drill a ream and there's no coolant there, you're going to have a problem burning up your tool. This goes really fast. So we have a way to adjust the coolant for each of the different tools. So I want to show you how to do that. First of all, I'm going to call up tool number 1, MDI T1 ATC. There's tool number 1. I'm going to put the tool offset screen up. Press it a couple of times till I got it. One of the columns here, this is tool numbers, this is coolant position right here. And then here's your tool offset. So I'm going to go to the coolant position. In this case, it's programmed for number 2. I'm going to turn the coolant on. Would you shut the door over there? Pick it up. Notice how the coolant's too high. Right over here, there's a little bit that says coolant up and coolant down. That button there? That's about the right position. Now, I'll just cut the coolant off. Down here at the bottom, the position I just went to was coolant position number 8. Programmed is number 2. So when it does the tool change, it would move to position 2 every time right now. The number that I want is number 8. So what I'll do is you have to add or subtract to get that number. Since I've got a 2 there and I want an 8, I'm going to put a 6. Press enter. Now there's an 8 there. Every time tool 1 gets loaded, it will go to position number 8. I'll bring my machine, let's see, T2, ATC forward and reverse. Needs to make a couple of changes. Stay out of the way. Now, I want to bring my little cursor down to coolant position, be sure I'm on the right one. I'll turn the coolant on. And that's not too bad. That's position, it's still position number 8 down here. Notice I can bring it up or down. It looks like position 8 would be a good place. Programmed in here is 5. So what I'm going to do is put a 3 in and press enter. Now there's an 8 right there. Cooling off.